Welcome everyone. My name is Jacob Hess, and I'm here to take you from zero to engineer.
Welcome to the IP addressing lesson. Well, you will learn how to dissect an IP address, an IP version 4 address that is, inside and out. And also, you'll understand what a network ID is, what a subnet mask is, what a CIDR notation is, and you'll generally be able to convert binary to decimal and vice versa. So this is going to be a great lesson where you really learn the ropes of IP addressing and get started with figuring out what all this binary stuff is and what it means. And then we'll do some practice exercises. So let's go ahead and get started and look at our agenda for this lesson. We'll start out by discussing what binary digits actually are. We'll also do some 8-bit binary to decimal conversions. We'll look at an entire IP address in binary format. Then we'll dive into network IDs and subnet masks and figure out how to calculate our subnet masks and figure out what our network ID is from our subnet mask and these different types of things. It's going to be really good. This is super important for any network engineer or IT professional to know. This stuff is the basis for a lot of what's to come. And then lastly, we'll wrap it up by discussing the IP version 4 class system and what the classing, the address classes actually mean. So let's go ahead and get started. All right, let's look at some binary stuff. So by this point, you're probably thinking that binary is just kind of a series of ones and zeros that just goes from one host to another or just goes across your screen, kind of like this, right? Well, it is actually that. Binary is that. But those ones and zeros that are flying across our screen can mean some specific stuff, of course. We know that, right? So we'll learn what those numbers actually mean in regard to IP addressing. And to reinforce your understanding of binary ones and zeros, we need to know that a 1 or a 0 is an on or an off. A 1 means on and a 0 means off. A 1 means there is signal, a 0 means there is no signal, right? Remember that? So this is probably something that you didn't know. Well, you may, but this is a cool little tidbit of information. If you look at a switch, like on the back of your computer, it may have a line and then a circle. As you can see here on this particular switch, we have a line here and then a circle here. Well, this actually means on and off. This is a 1 and a 0. So if you turn this up, you're actually turning it on. And if you turn it down, this switch down, you're turning it off because it's a 1 meaning on and a 0 meaning off. That's a kind of a cool tidbit of information. You've probably also seen this symbol before. And this is a power button to a computer, right? This also could be a power button to some other piece of electronics. But really, this is a 1 with a 0. You may see it with a fully enclosed 0 as well, but that's how this was configured, or that's how this was created, is to represent a 1 and a 0, which is on and off. That's why it's on a power button. Interesting fact, isn't it, guys? So that reinforces the fact that we see binary, sometimes we don't even know it, and it means things, and we don't even know it means something. And the basic form that a binary can tell you that it means something is an on or an off. All right, let's move on then and discuss what these ons and offs actually mean in more detail. So here we have something I'm going to call the most important chart for IP addressing and subnetting that you can ever create. That's my name for it. I'm not going to call it the golden chart or the fantabulous chart. I'm just going to call it the best chart you should ever know for doing IP addressing and subnetting, because it really is. This is all you need to understand, or you need to understand how to manipulate these numbers here and how these numbers are created. And it's really actually easy. It's super easy, guys. And I'm just going to go into a little bit of a rant here about subnetting and the fact that the way subnetting is taught these days, well, and actually the way it's been taught always, has been with using formulas as the primary method. You'll have all these different charts and these different formulas like 2 to the b minus 2. Well, when we do our stuff, guys, it's all going to be just by binary. But understanding these numbers here we have on the screen is the way that we can make our lives so easy. And when we get into subnetting, which we're not going to do in this lesson, but when you get into subnetting and you understand this thing here, it's going to make your life so easy, guys. And you're going to really always know what you're doing. It's going to bring everything together. If you've taken any subnetting classes before, or you've done subnetting in the past, and you've had a hard time, well, this is going to clear it up for you guys. I guarantee it. It's really great. So here we have our great chart, right? And what this chart actually represents is binary values. So I'm going to put up on the screen some placeholders for some digits. Now there's 8 placeholders here, meaning that there are 8 binary digits, right? So we could fill these placeholders with either a 0 or a 1, and they would be representing if we're turning on or off these bit fields, right? And again, each one of these bit placeholders represents the number that's above it in the chart that we wrote. So let's go ahead and fill this with a series of 1s and 0s. All right, we have some 0s and we have 1, 1 here. And I'm going to describe exactly what this calculates out to. But before we do that, I want to make sure you understand that we're looking at 8 binary digits. And these 8 binary digits together are considered to be an octet. So it's called an octet because oct means 8. So an octet is 8 binary digits and an IP address and a network ID and a subnet mask. They're all made up of 4 separate octets, which are 4 separate groups of 8 binary digits. And if you multiply 8 times 4, that gives you 32. So there's a total of 32 binary digits. But the point is, we're looking at an octet here, right? And we are concerned with figuring out what this octet means. So each octet is built exactly the same way. Whether you're talking about an IP address, a network ID, or a subnet mask, these bits to reference are always exactly the same. Starting at the right in the octet, it goes from 1, then 2, then 4, then 8, then 16, 32, 64, 128. All right? So that's how it works in the single octet. So now on to figuring out what this actually means. We said a binary can be an on or an off, and that's why we represent it with a 1 or a 0. So anywhere we have a 0, we're saying that this bit field is actually turned off, or this bit is turned off. So 128 is turned off in this example, 64 is turned off, 32 is turned off, all the way to 2 is turned off. The only thing here that's turned on is the bit that is represented by the number 1. Right? So when this is turned on, it's a 1, right? So this means that this entire octet turns from binary into a decimal 1. Makes sense? If we added this 1, or if we turned on, let's say we turned on the field under the 4, it would actually then be a 5, right? Because the 4 would be turned on and the 1 would be turned on. So that would be 4 plus 1 equaling 5. If these were all offs, then it would be a 0. All right, let's do some more of these. Let's go ahead and put up another series of 0s and 1s and see what that writes out to. All right, so now we have cleared out as well everything from 128 to 4. Cleared out meaning it's all 0s. But we have the 2 and the 1 turned on. So with the 2 and the 1 turned on, what does that mean? We have 2 plus 1, right? And that equals 3. That's pretty easy. Let's look at another one. Let's look at this one here, where we have the 32 field turned on and also the 1. So 32 plus 1 equals 33. I knew you guys could get that one. All right, let's look at another one. Here we have only the 128 bit value turned on. So what does that mean, guys? That means our decimal value is 128. Well, let's look at another interesting one. Next, we're going to turn on all the bit values after 128 and see what that adds up to. Here we have all the bit values after 128 turned on. So to figure out what this is, we could add 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And we would find out that that actually equals 127. So what's so magic about this? Well, these adding up are always going to be 1 less than the number ahead of it. So we could already know that if all these were on, that they would equal 127 because this 1 less than this value here, 128. And let's say that we also had 64 turned off, right? And we had just 32 and below turned on. Well, we'd know if we added those up, that would equal 63. Does that make sense? I'm sure it does. Let's do that one more time, actually. Here we have 1 in the 128 field, and everything else is turned off, right? So that means that this octet turns from binary to decimal, meaning that it's 128 in decimal. Now, if we clear everything out, and we just fill all these up with 1s below 128, this binary, this 0, 1, 1, 1, 1, 1, 1, 1 binary translates into decimal 127, which is 1 less than 128. The reason why I'm doubling down on this and telling you guys this twice is because we will utilize this to really super easily figure out things regarding subnetting in the future when we do our subnetting lesson. So I want you to get this point here. So that's really how we dissect a octet. That's how we dissect 8 binary bits and how we can change them into decimal format. So you could play around with this as much as you want. I do have some practice exercises regarding this, but you can just figure out your own numbers. Now, if you add all of these together, well, what does that make, guys? If we have all ones in these fields, what does that make? That makes 255, which is why you've seen this number before. When there's all ones in an octet, it equals 255. So you're never going to have a number higher than 255 in your IP address, in your decimal IP address. You will never see a number higher than that. So you can think, if you want to get anything 255 or below, you could figure out what that would be in binary, right? So we can do this with 8 bits. We can write in binary 1 all the way up to 255 by changing these from different combinations of 1s and 0s. Pretty cool stuff. If you haven't seen binary before, you can see how it's so useful. It's really awesome. All right, so let's go ahead and move on to our next exercise, guys, where we will look at an IP address in binary. So here we have an IP address, 192.168.1.5. And if we break this out into binary, it'll look like this. We have 4 different octets, right? And we have 4 different sets of decimal numbers that translate to 4 different sets of binary digits, of 8 binary digits. So it's 8 here, 8 here, 8 here, 8 here, totaling to 32. So that's why an IP address is said to be 32 bits in length. Now, we could sit here and try to figure out what 192 is by understanding these binary digits, right? We could figure out what 192 is, what 168 is, what 1 is, what 5 is, and we could say, oh, that's how we came up with this binary octet. That's how we came up with this binary octet. Now, we could do that in our head if we want, but guys, it's much easier if we use our awesome chart. So let's go ahead and use our awesome chart and do this again, or look at it by having our chart up, rather. Okay, so now we have 192, right? Well, 192, we can look at our chart. Remember, this is 8. It's just 8 digits. And let's look at the 192 decimal value. And if we didn't have this up here and we're just trying to figure it out, we would say, okay, what do we use in our chart to get to 192? Well, we'll use the 128. You always start out with the highest number in the chart you can, which 192 includes 128, right? So then you start adding things up. So we start with 128, and then we add 64 to 128. Well, 128 plus 64 actually equals 192. So there we have it. We know that our binary will be 1, 1, and then 0, 0, 0, 0, 0, 0, because we already got to 192, right? So we could write that down. Then moving on to our second octet here, as it's called, the second octet, what can we add up to equal 168? Well, we can start with 128, again, right, because 168 includes 128. But then if we added 64, that would be too high, because that would be 192. So instead of adding 64, let's add 32 and see what happens. So 128 plus 32 is what, guys? 160. So from 160, how do we get 168? Well, we just need to pop an 8 in there. So now we know that these will be ons. These will be 1s in our actual octet, our binary octet. So it will be 1, 0, 1, 0, 1, 0, 0, 0. That's how we got that figure there, guys. Now let's look at the third octet, as it's called. In the third octet, we have a 1. And a 1 is easy, right? It's just all offs and then a turning on of the bit in the 1 value, in the bit that holds the 1 place value. All right, that's how we get a 1. And then 5. Let's look at 5. So 5 is pretty easy as well. If we have our really awesome chart up here, we can really quickly find out what 5 is. It's just 4 plus 1, right? So it's going to be 0, 0, 0, 0, 0, 1, 0, 1. Pretty cool, right? This is binary, guys, and this is how we create our IP addresses. It's really super sweet stuff. So there's a total of 32 binary digits that are broken up into 4 octets, as we can see here, right? 32 binary digits broken up into 4 octets. And remember, an octet is 8 binary digits.
Jacob Hess here. Thank you guys for viewing the video. I hope you really enjoyed it. And I'd also like to remind you that if you're truly serious about your career in information technology, be sure to check out our Career Blueprint and Engineer Training Program at www.zerotoengineer.com.